Hey guys, today we're going to continue our study of functions with absolute value. I will go ahead and tell you that there are quite a few things that deal with absolute value. And if we were in a regular class setting, this is something that we might work on over a couple of days. But because it's a video, I'm just going to do everything at once. As always, pause your video as much as you need to. Take it in pieces if you would like. Just please make sure you're taking good notes and making sure that you mark where you have questions. So one thing we need to make sure we know about absolute value is that it is a distance from zero. So since absolute value is a distance, it's never negative. Now that's inside the bars. If you have a negative outside the bars, that's a whole different story. But if it's inside the bars, it's always positive. So the absolute value of 5, the absolute value of -5, the absolute value of -5 minus 1, the absolute value of -5 plus 1. It's always positive. So one thing that you need to make sure that you do when you solve algebraically is in this highlighted box here. When you solve algebraically, you isolate the absolute value expression on one side, everything else on the other side. Think of it in terms of your variable. Consider two cases. The value inside the absolute value is positive or negative. Sometimes there's no solution. Always check your solutions. So you're going to set up, you're going to hear me say this a lot, set up two ways. One's positive, one's negative. So I'm going to do a few of these, and then I'm going to let you pause your video and work on a few of these, and then we will look at the next section. So the absolute value of x is equal to 3. The first way, remove the bars. The second way, remove the bars, make the number on the other side negative. Now, because this is just x equals 3, that's all you have to do for that one. For part B, I'm going to put this kind of in a little box here. For part B, remove the bars, make the quantity on the other side negative, and then solve both equations. So 2x equals 8, x is 4. 2x is -2, x is -1. Part C, you have a set of absolute value bars equal to a negative number. That is no solution. Absolute value bars cannot equal a negative number. Write that in words if you need to. Absolute value bars cannot equal a negative number. Part D, isolate the bars. Absolute value of 4x plus 6 equals -5. Same thing as C. No solution. Absolute value bars cannot equal a negative number. In part E, when you have a binomial on the other side, for your second equation, you just distribute the negative. So remove the bars. Make the quantity on the other side negative. Don't forget to put that in parentheses. So combine like terms, x is -3. And distribute. Combine like terms. Especially when you have a variable on the outside, you want to make sure you check. So 3 times -3, -9. -9 plus 2 is -7. So that would be 7. 4 times -3, -12. -12 plus 5 is -7. So that one doesn't work. 3 times -1, -3. -3 plus 2, -1, which absolute value is 1. 4 times -1, -4. -4 plus 5 is 1. So x equals 1 would be your answer for part E. So we have no solution for D, no solution for C, 4, and -1 for B. Turning to your next page, now we're looking at inequalities. You're still going to set up two ways. First way, remove the bars. Second way, remove the bars, reverse the inequality, and make the quantity negative, and then solve. X is greater than 25. X is less than 15. So your answer is X is less than 15 or X is greater than 25. Part B, remove the bars. Remove the bars, reverse the inequality, and make the quantity negative. X is less than or equal to 7. X is greater than or equal to -1. Now, how do you know if it's an and or an or? It tells you right here. It's an or if X is greater than A or less than -A. It's and if it's less than A and greater than -A. So that means that on a number line, the and is what's in the middle. So here we have less than or equal to 7, greater than or equal to -1. So that means -1 is less than or equal to X is less than or equal to 7. So that would be an and situation, and that would be how you write your answer. Isolate the bars and write two ways. It's a good idea to go ahead and write the two ways just so you don't forget. So X is less than 1, X is greater than -7, -7 less than X less than 1. Now, because we have a less than or greater than, because we are dealing with inequalities, negatives here are okay. So I would like for you to pause your video, work these out, set them up exactly the same way as we did 1, 2, and 3, and then come back and check. Part E, X plus 1 less than -6, X plus 1 greater than 6, X is less than -7, X is greater than 5, X is less than -7, or X is greater than 5. How did you do on that one? X plus 4 greater than -3, X plus 4 less than 3, X is greater than -7, X is less than -1, -7 less than X less than -1. As always, mark if you have a question so that we can talk about it when we get a chance. All right, the next thing we're going to look at is how to graphically solve an absolute value um, equation. So the absolute value bars on your calculator, math, right arrow key, enter. So on this page, we're going to just graph them, but then we're also going to talk about how to solve by graphing. And then we're going to talk about the different pieces, the different characteristics that I want you guys to find so that you'll know how to graph it and then analyze your graph. So math, right arrow key, enter, X, graph. And then just plot. Mine's not on the Zoom 6, but it's going to look the same. So I want you to just plot this for part A. We're just graphing in parts A, B, and C. If you want to pause your video, you're welcome to do so. Graph part B, absolute value of X plus 2. Notice where your vertex is at -2. And then math right arrow key, enter X, right arrow key plus 2. That plus 2 should not be in your bars. And notice the transformation that takes place. We've shifted up. Notice the width of our V, because that's what an absolute value graph looks like, a V. Notice that has not changed. When we solve by graphing, we should have an answer. So we should know where it crosses the x-axis. So we're looking for x-intercepts here. So I want you to pause your video and I want you to graph A through D. Okay, these are the graphs that you should have gotten. Now, when you graph B, C, and D, you should graph this as absolute value of x minus 8 minus 2, absolute value of x minus 3 minus 5, absolute value of x plus 1 plus 5 minus 3. You got to isolate it. So what we're going to do is solve. Where does it cross the x-axis? Plus or minus 4. Where does it cross the x-axis? Use your calculator to determine that. 6 and 10, negative 2 and 8. And this one is no solution because it doesn't cross or touch the x-axis. Now, one thing I want you to make a note of here. When you graph these, in addition to graphing and solving, you are going to need to find these graphical characteristics. We're not going to do this right this second, but we are going to do this before our video concludes today. So I want you to be thinking about these. These are the pieces you're going to have to find based on the graph that you get from your calculator. You're going to have to be able to find the domain, the range, end behavior. What's it doing at the end? Where is it going? This one is going to start as x approaches infinity, f of x approaches as x approaches negative infinity, f of x approaches. And you'll fill in these two pieces here. And then using interval notation, where is your graph increasing and where is your graph decreasing? And as I said, these will be in interval notation using your parentheses and your brackets. So make sure you make a note of those. We will be looking at those characteristics here in just a couple of minutes. All right, the next thing we're going to look at is a page that is a step justification. And the step justification is simply what's going on in the problem. Julia is solving an absolute value inequality in class and has become stuck. Show Julia the next step and write down the explanation for that step so she can reference it on other problems. All right, so number one is just the problem. It's what's given. So what we want to do next is see what has happened from here to here. Well, the 2 is the same. The absolute value of x plus 5 is the same. The negative 3 is not there. The inequality is the same, and the 10 has become a 13. So what's happened is she's begun the process of isolating these bars by adding 3 to both sides. So what has happened from here to here? Well, the 2 is gone. That's the first thing I noticed. Bars are the same, inequality is the same, and the 13 has become a 6.5. So what's happened here? Divide by 2 on both sides. To isolate the absolute value bars. Now, on a step justification, it's not about shortcuts because what you're doing in a step justification is you're proving that you know how to solve the problem and what's going on from one step to the next. So what happens in step number 4? The bars are isolated. So we're ready to take the absolute value equation and set it up 2 ways. So we have the absolute value of x plus 5. So that's just going to become x plus 5 less than or equal to 6.5. And x plus 5 is greater than or equal to negative 6.5. What's left is we're going to solve and graph. And we haven't looked at an absolute value inequality graph yet, so we're going to do that here for the first time. So subtract 5, x less than or equal to 1.5. Subtract 5, and x is greater than or equal to negative 11.5. So what we're going to graph on is a number line. So we have negative 11.5 and 1.5. So this is, I'm going to start here first. Close circle, shade right. Close circle, shade right. Close circle, shade left. So there's my graph, my answer, negative 11.5 less than or equal to x, less than or equal to 1.5. So what you've done there is solved a problem, as well as state what happens in each part of your problem to justify what's going on and to prove that your answer is correct. We've talked about using a graph to solve an absolute value equation, but now we're going to look at what happens in our calculator. We're going to use our calculator to solve the equation. No writing down except the answer. So using a graph to solve an absolute value equation, no matter what your equation looks like, follow these steps. Set the equation equal to 0, graph it in your calculator. Where the graph crosses the x-axis is or are your solutions. And what if the graph doesn't touch or cross the x-axis? There's no solution. Now, if you will make y1 your equation and y2 equal to 0, we can very easily find these intersection points. All right, we're ready for number 1. So we have math right arrow key enter 2x plus 7, right arrow key minus x plus 4. Set it equal to 0, and then y2 is 0. Pause at any point in time to catch up. Well, that one's pretty easy. It doesn't touch or cross that red line. So this one's no solution. Y equals clear. 3, math right arrow key enter, x plus 6, right arrow key minus 9x plus 6, graph. All right, look down at the very bottom. If you can't see where the solutions are, hit zoom 3, enter. What that does is zoom out your graph. Zoom 3, enter. So there's one solution. And I'm still not seeing another solution. I'll try it again. And one last time. So it appears that this graph is only going to touch one time. So I'm going to go back to my normal screen, zoom 6, and look to see where it crosses my x-axis. Should be very clear. It crosses at 4. Now, I'm going to make sure. To make sure, you hit the following keys. Second, trace, 5, enter, enter, enter. It tells you right there you cross at 4. All right, problem number 3, y equals clear. Math right arrow key enter, 2x plus 7 graph. Second, trace 5, enter, enter, enter. Negative 3.5 is negative 7 halves. All right, I would like for you guys to pause your video and work on problems 4 and 5. All right, for number 4, you should have gotten 1 and 5. For number 5, you should have gotten negative 8 and 14. That's one where you had to zoom out to find your other piece. Second, trace 5, enter, enter, enter. All right, that concludes the notes portion. What we're going to do now, other than the characteristics for graphing, which we're going to look at in just a second, this begins your assignment, solving absolute value equations, inequalities. and then graphing. And this is the page that you're probably going to want to do a couple of things. Either number one, write down your characteristics on notebook paper, or number two, create a Word document and put all your characteristics on there, print it out, and then you don't have to rewrite them every single time. I will tell you that you're going to have to do that on your quizzes and on your tests. So you want to make sure that you have plenty of space for that. So I'm just going to do one or two on each page so that you'll have an idea of what you're going to be doing on your practice. You don't have to redo them, but I would like for you to at least write your answers down when you do your practice. All right, so we're going to set up two ways. Divide by 3. And x is 3 and -3. I'm going to do number 3. B over 5 equals 1. B over 5 equals -1. Multiply by 5. Multiply by 5. So that's what you're going to do on these. For solving absolute value inequalities, you're going to solve in graph. Set up two ways. And I'm going to finish them down here. So n is less than or equal to 12. N is greater than or equal to -12. So these are closed. They're closed if they're or equal to, open if they're not. So greater than -12, less than 12 means we shade in the middle, and then we write our answer, -12, less than or equal to n, less than or equal to 12. And for number 3, x over 6 greater than or equal to 5, x over 6 less than or equal to -5, x is greater than or equal to 30, x is less than or equal to -30. So less than or equal to -30, don't forget the arrow, greater than or equal to 30, and don't forget the arrow. And then you can just put an or there, and that would be your answer. All right, here's where we're going to do things just a little bit different from what we've talked about. So we're going to graph, math, right arrow key, enter, x minus 2 minus 4. And we're going to put the graph on our paper. I got a zoom 6. We're going to put the graph on our paper so it looks like -2 and +6. And because you have a grid, you want this to be as accurate as possible. So I'm going to trace to figure out what this point is down here. It looks like 2, -4. And then I'm just going to connect my dots, creating my points, creating my graph. And my solutions are x equals -2 and +6. Now, a couple of things I want you to look at. First of all, the graph, starting left to right, the graph is going down. It hits a point, and then it starts to go up. So this would be your decreasing interval, and this would be your increasing interval. What's happening for your domain is you have no restrictions on your x values because you keep on going in a negative direction for x, and you keep on going in a positive direction for x. So our domain would be -infinity to infinity. Your range is your y values, and you'll notice on your y values that you have a minimum. When you have a minimum or a maximum, which you should have on these problems, you're going to have a restriction on the range. Well, this minimum point is 2, -4, and the absolute value graph opens up, which means -4 is your lowest value. it is included on your graph. So our range includes -4 and goes up to infinity. In behavior, as the x values approach infinity, what is your graph doing? It's continuing to increase to infinity. As x approaches negative infinity, your graph approaches positive infinity. That's all you have to do there for in behavior. We've already talked about increasing and decreasing. You are decreasing from negative infinity. These are x values. From negative infinity to 2. And then you are, I'm sorry, I wrote that in the wrong place. You're decreasing from negative infinity to 2. And then you're increasing from 2 to infinity. Keep in mind that we probably should put those in parentheses because you're not increasing or decreasing at a point. So you're decreasing until you hit that point, and then you're increasing because you're at a minimum value. So you're going to do that same thing, abbreviate if you want. You can put this as capital I, capital D. And again, if you want to print this out on a Word document, you're welcome to do so. So you're going to do your graphing, you're going to solve, and you're going to do the characteristics for this page. All right, guys, that concludes our section on absolute value. If you have any questions, please let me know. I hope y'all have a great day.